first of all, I'm super excited to be here. That first amazing presentation this morning, how did they do the slides? It was so sweet. I have a cool animation. I thought I was cool, but it's a tough life. So I hope you have a good time over the next couple of days. I'm really looking forward to the talks myself. This is my first time to New York City, so please give me suggestions if you have any. So it's fluff time. This is my time. This is my favorite part. I get to talk about how I got to be here, and I'm happy to share my story with you. So it all started about a year and a half, I guess now. I got a new job at Netflix. It was super amazing. I got to be put on this brand new team. We got to do some greenfield projects, which is always way fun. We evaluated what tools or languages we wanted to use as a part of this. A lot of teams at Netflix use Java. Some are using Ruby, Node here and there. We weighed up in the pros and cons, but ultimately we chose Apollo, GraphQL, Node, TypeScript with very little innies. I'm very proud of that. So over the year or so that I've been working on this project, our team often eats lunch together, and they would always want to know how this project was going, because we had adopted a lot of these new tools, and in particular the GraphQL segment of this, there was a lot of interest in. And as I learned more and more about this technology, I'd always rave about the cool new features, or how it was different than REST, or what I was confused about, or what I was learning. And I didn't really realize I was doing this, but every lunch I would be like, oh, I'm not really sold yet, after every single time we would talk about it. So I kind of inherited this catchphrase of not being sold yet, even though every day I'm talking about how cool it is. So after a couple of months, my friends kind of convinced me to give a talk from a skeptic's point of view. So I did, and I've given this talk once before or so. But the first thing you do when you get accepted to give a talk, or when Anna asked me to come talk on this, is you buy all the books to try to figure out what the GraphQL is. So I did that. Anyway, I'm here today, and I'm excited to be here. I really think this place is awesome. I came here last night and I saw the guy talk, walking on the tightrope. That was so cool. So thanks so much for inviting me to be here. I hope you've heard of this thing called GraphQL. If not, you're probably on the wrong talk. But I really hope that I can shed some light to the power that I think GraphQL really brings. And if nothing else, hope you give me some talking points if you're already sold to go tell your other teammates. The truth of it is, until recently, I wasn't really that big of a fan of GraphQL. I haven't really used it in any production capacity. I hadn't built any side projects with it. And honestly, I thought it was just this new front-end fad that would come and go. But once I started looking into it, really building things with it, digging into it, I noticed the things that I liked about it weren't actually much of the technical parts at all. I really enjoyed what it enabled for an organization and helped solve problems I think people face day to day within the big teams. So since then, I'm a convert. I'm a GraphQL enthusiast. So this is my face. Like I just mentioned, or what Mobus just mentioned, I've just moved from Australia. I like video games, whatever. So I'm really excited to be here, so please feel free to come talk to me after this. I'm happy to share all of my experiences and thoughts around this topic. So don't be shy. So as I mentioned earlier, I do work at Netflix, and I've been there a little bit over a year. It's gone by amazingly fast. I feel really grateful to be a part of such a great organization and team within Netflix, and they have a very interesting culture, very unlike anywhere else I've ever worked. I think I've learned a lot and grown a lot professionally as well as technically. But before we get started, I want to share some context around how Netflix actually operates and works. So for the topic of this presentation, there's basically two main organizations. One is product or streaming, which you or I are hopefully are all familiar with, like recommendations, downloads, things like this. And the other one that's less known about is the content engineering space, where we actually help build and facilitate all the tools that go into creating these shows that we all watch. And that's the one that I work within. So what does that really mean? So let's say you want to make a band. Great. Well, you need to find people to be in your band, right? Sweet. You got to find a place to practice. You got to figure out what kind of genre of music you're going to play. And then that's just the start. You got to get your first gig. You got to record your first album. You start selling some CDs. Where do you sell your CDs? What languages do you distribute this in? Stuff like this. And you got to work out who gets paid. Does the lead singer get paid twice as much because they sing? That doesn't make sense. So anyway, a whole lot goes into making these shows, and that's basically where our teams come in. So in short, we help create all the Netflix originals. We're building the largest internal studio in the world, and we have to do that in a way that will scale, not with people, but with technology. So we often look at what technologies we can use to do this, and we really think that GraphQL is going to have a big impact on that role. So Netflix has heaps of teams, an ever-larging, growing amount of teams, and each team has the freedom and responsibility to build systems however they see fit. There's no one dictating way of ruling us, building systems. It's a very, very free form. So this helps foster innovation, creativity, and empowers individuals to build things the best way possible. But this talk is going to specialize in particular within my team within my organization. But no, more and more teams are starting to use GraphQL across the entire company. So Netflix's culture, like I mentioned, is very different than everywhere else. They like to take really big bets. So they started getting DVDs and shipping them around the world, and now they're one of the largest streaming platforms in the world. So they didn't do that by always playing the safe bet. So we pride ourselves on making these big bets and like sunshining when they mistake or when they fail. But we really believe that GraphQL is going to drive us forward in the next phase of our development cycle. So my team has been building a single entity graph over the last year or so. We have a lot of different downstream services. So some of them are gRPC integrations, some of them are Java, some of them are Ruby, some of them are REST. The thing is, we don't really care. We define a GraphQL schema that's a product-focused representation of our domain, and then we build UIs against them. And then however we feed the data to that graph is kind of irrelevant for allowing us to move very quickly. So we've been showing this off to other people, and they want it as well. It's definitely spreading within our organization. Over the last many months, many of these graphs, single entity graphs, are starting to emerge. And people want to keep adding their entities to ours. They want to get ours into their systems. And it's just really kind of becoming a contagious system within our organization. We are still really early on in this journey. I think GraphQL is still a fairly new technology, and we've only recently been using it. So I'm excited to hear from people in this audience. If you have more experience or things you can help us learn from, please come tell me those things. So why should we all care about GraphQL? Why are we hosting a conference? And why are you all here listening to me talk about it? At the end of the day, I think GraphQL is really good for teams. It fosters team communication in an unmatched way. It radically improves the way front-end and back-end engineers work together. And it acts as a living source of documentation for your taxonomy of your API of your system. It's a really powerful tool. So let's dig into why I think it's good for teams. So this is a really big rock. So is this one. Any guess what this one is? So these are all monoliths. And it might be an unpopular opinion, but I think monoliths are really great. They have their own problems, I'm sure. Maybe you all experienced them in your past. But I would argue that a lot of successful companies started as a monolith. And there must be some reasons for this. And if you look into them, they have some really interesting characteristics. All the code lives in one source, single source of control. Single system. Each commit is an atomic action. It's easier to debug because it's all in one stack trace. You generally don't version because you're the only client of yourself, generally. I guess you can summarize it to say information is easy to find when it's in one place. It might be a big ball of mud, but you love that ball of mud, and you know how to find it, dig your way through it. So on the other hand, though, distributed systems are inherently complex. So they're only as good as the internet in between them. You have to figure out some way to pass messages between them. You have distributed transactions. You have eventual consistency. Some of the buzzwords I was able to find on Google.com. So anyway, information is harder to find when it's spread across everything. So everything is isolated and separated. There's definitely a lot of pros to this, but I would argue it's much more complex. So why do we opt for the more complex almost often of the two? As I mentioned before, I think most successful products started as a monolith, but we almost always choose the harder of the two. I don't believe it's a coding problem at all. I think it's a people problem. Because when you break it down, communication is very complex. It's inherently lossy. It breaks down at scale. It's just an interesting topic in general, where I have a thought in my mind, and I want to put that same thought in your mind, and all I have to do that is with words. And that's just challenging one-to-one, let alone when you have 30 or 40 people on your team, all trying to move the same direction. So computers will do what we tell them to. People aren't always so easy. So I've been mixing these words on purpose here and forward. There's a really good talk by Rich Hickey called Simple Made Easy. It covers the main difference between simple and easy, complex and hard. You should really go watch that. It's much better than this one, but not right now. But I'll try to summarize it very quickly. So simple is composed of a single element. It's very easy to see where one thing starts and where it ends. So it's a straight rope. Pretty simple. On the other hand, this is a complex system. So there's one rope. It's very hard to know where one starts and where one ends. They're really combined together. So this is interesting, but let's see how this comes into play with our day-to-day interactions within a team. So if you look at this amazing diagram that I prepared earlier, each circle is a person, and each line is a communication path between a person to a person. So if you have 3 people on your team, you have 3 lines, and they're very simple. They're not complected. They're very one-to-one. If you double that size of the team to 6, now you have 15 lines. great. And if you go to a team of just 12, it becomes a very complex matrix of interactions within people in your team. So as these lines generally get bigger, or more numbers of them, you usually need more process. You might have impromptu daily stand-ups, or you might have Scrum management, you might have agile coaches, whatever. Like, it gets way more complicated as you progress in the system. So how do we scale this? There's no way that 12 people or 15 people or 30 people all working in one system can really work efficiently, quickly, all moving in the same direction, because the cost of communication is too complicated and too high. So the most logical thing, which I'm sure is no surprise to much of you, is to break these into smaller teams. So we go back to the dream team of 3 people, 3 lines, not very complicated system. With the same number of engineers, you can have a much more efficient, well-oiled machine doing their little bits. So with microservices, we optimize for independent teams. Each team can become their own dream team, moving very quickly in the same direction, and the cost of communication is quite low. This empowers single teams to move very quickly. But that's only one team. So what happens when these teams need to work together? You know, data requirements very rarely ever live on just one system. You need to push and pull data between them. So how do we do that today? There's very many number of ways, but a very common way is REST. So I'm not here to bash REST. REST has gotten us a very long way and has a lot of good things about it. Like file uploads, for example, do that with REST. GraphQL is so hard. But the main issue I still have with REST is I feel like it's easy to make mistakes with REST. Let's say I have a resource of person. Is the plural of this person? Is it people? Is it persons? Sure, I'm sure the spec talks about exactly what to do, but would you know what to do, or would your teammate know what to do when they go make this endpoint? What about versioning? So great, you want to make a breaking change. You slap everything under a V2, make your new code, you deploy that new resource that you've added, that you've changed. Do you bump all the existing ones to V2, or do you now have a V2 and a V1, and all your clients need to know which one to hit? I feel like you've added a complicated system to a complicated system. Again, I'm sure the spec talks about what the best way to do this, but it's been done differently at every company I've ever worked at. So the mesh is back, except it's not with people, it's with many, many systems. And that's much more challenging over the internet. Each new client, each new resource has to be created manually with all of its nuances. A client needs to know which API do I talk to, what are the auth requirements, what are the API versions. It just becomes a very complicated system, which is a costly thing. So I believe GraphQL also goes a step further beyond REST, and it helps an entire organization of teams communicate in a much more efficient way. It really does change the paradigm of how we build systems and interact with other teams, and that's where the power, I think, truly lies. Instead of the backend dictating, here are the APIs you receive, and here's the shape and the format you're going to get, instead they just express what's possible to access. The clients have all the power between pooling in the data that just what they need. The schema is the API contract between all teams, and it's a living, evolving source of truth for your organization. So gone are the days of people throwing code over the wall, being like, good luck, it's done. Instead, GraphQL promotes more of a uniform working experience amongst front-end and back-end, and I would go further to say even product and designer can be involved in this process as well to understand the business domain that you're all working within. So the schema itself can be co-developed amongst anyone because it's just an SDL or a schema definition language that has no implementation detail. It's just like some syntax that describes like what are the entities in your domain. I'm pretty sure most people could write these if they're familiar with your domain apps. No more making funky APIs to meet your graphic needs of your UI constraints, and no more backends giving you like, here's what you have to use because it works for us. Instead, you build a schema that is a representation of your business, and I would argue that schemas are a superset of all use cases, because once you have this system defined in a very neat way, many teams can build against that without having to change much. So instead of exposing database tables over an API, which I feel often is done in REST, instead you can build a product-focused schema that really reflects your business and what is possible to do within this domain. And I think that is what really powers the clients to build amazing UIs and prototype very quickly, whether that's on an Android device or an iOS device. They can all leverage the same system that is product-focused. So have you ever been in a meeting where people are talking about slightly different things, users, guests, admins. You're all trying to figure out what you all mean, and then you go back to your editor once you've all kind of aligned on what you're going to go build, and you convert it into yet another word. I think it's a very common problem within most coding organizations, because code naming is just challenging. But people don't have ubiquitous language to define like what their system actually is and what it does. But I believe GraphQL promotes that by nature of having one schema that reflects your app entities. So if you're all discussing the same words, meaning the same things, whether you use GraphQL or not, I think having that ubiquitous language is a generally good thing to do in a business. But if a technology can drive that as a way of implementing it, that's only going to bring amazing results, I believe. So if you have this product schema, you have your designers, your PMs, your other engineers on board, it's going to change. So I complained earlier about REST and versioning. I feel like it's a lot easier to do this with GraphQL because you never delete anything. You just always go forward. I'm just kidding. You can delete things, but it's much more of an evolution. So you keep adding fields. You deprecate old fields. You do some analytics. You say, hey, look, no one's using that old field. Now it's safe to remove that thing. So there's amazing tools like Apollo Engine, and I'm sure there'll be many others that come out that do auditing and like client detection of what's actually being used, what's slow, and you can see your graph for what it is and just move forward. Change the shape of the message, deprecate the old things. So it's a rolling forward development cycle as opposed to breaking changes, big bang, V2. So one of the biggest fears I see when people are faced with GraphQL is that they have to rewrite the world. So you already built your castle, you have your amazing infrastructure, you have all these microservices, but in reality, none of that has to change. You can leverage your existing tools and platforms and just enhance it with GraphQL. You don't have to rewrite the whole world. So what this means for backend engineers is amazing. They can keep operating in their same development cycle. They can have their high SLAs. They can care about their gRPC endpoints that they maintain, and just wrap that with a GraphQL schema. If you have an old SOAP API that no one knows how it works, OK, treat it as such, make it a black box, expose the endpoints that you need to interact with it over a GraphQL endpoint. So you can continue to optimize what each team is best at while enabling everyone to move quickly and iterate on the UX of their product, or even allow other backend engineers to consume this graph if that serves their needs. So you have this product schema. Things are moving quickly, and you can evolve with it, ever requiring changes that come up. But what happens if you have a few of these entity graphs? I've been talking in the context of one entity graph. So there's amazing tools like Apollo Federation is coming out really soon, which is like a way to deploy an API gateway that can merge all of these entities into one graph. So it's really interesting. Some people have gone as far as automating this entire process with custom tools, but a lot of this open source work is coming out to be available to everyone. So what would this look like in practice? So for my amazing graph I prepared earlier as well, these teal boxes are the microservices for users, products, accounts, and reports. Each of these can have their domain entity graphs. They're small dream teams working really quickly, moving very fastly, and they define their own schema. They can push this up into a schema registry. This is like more specific implementation detail, but basically you want to merge these entity graphs into a way that you can track changes and updates and automatically code gen effectively this federated graph, which is one graph of all of the entities that then any of the clients can consume and then drive their products forward. So as a consumer of your PS4 or your iPhone, you don't have to care. You say, here's the one graph of all of my apps, business domains, context, entities, how they work. I go there, I get my information, I can build my systems. And as a microservice provider, you say, here's the graph that I own, here's the entities within them, and here's the schema of that, and then merge them together. So let's build our distributed monolith. We'll have a single graph, a single API team to allow teams to develop rapidly, all speaking the same language, moving quickly, and understanding the actual needs of the business. This will empower many teams to move very quickly. So I think GraphQL promotes a new type of service. It's a higher order service. It's like a giant map function in the cloud. Countless clients can develop against it and build whatever workflow or tool they need to make an impact within their business. So as I mentioned, my team over the last year has been building this single entity graph. Having this graph has really changed the way that we think about the information within our system. As I mentioned, we have many downstream services, and historically it's been, oh, this is the data we can get from here, here's the data we can get from there, and it's been very siloed of how we actually implement systems. But going to this graph model, it doesn't really matter. We just say, here's the information. What do we need to solve for the user to build our products? We can really dig into the complexities of like not where the data is stored, but what do we provide to people that need our tools. And this scales not even within our team. Sure, we built the graph, we know how it works, but other teams can go to our graph through a graphical tool and explore our schema and understand all the data entities within our system without even reading any of our documentation, without talking to us, without a meeting or a handover. They can just fetch the data very trivially within our system. So it's an optimization there as well. So it's a new way to answer questions that previously have been impossible to ask, or to answer rather. We see things as a unified model. But the thing is, this is just a start for us. The prize is bigger. Once you're able to answer these questions and you have this entity and how they relate to things, you can really start to change how you develop systems because you no longer need to care about persistence or things like this. Sure, those things do come up in terms of performance or like read after write, things like this, but those are implementation details. I feel like the graph schema allows you to change the way that you think. But the problem is, once you have one entity, you really need them all. Because, like I mentioned earlier with REST, one system rarely only has one entity within it. They need to push data between them. Things naturally relate to each other, and they often live within different systems. So to have a full graph of entities, you want to traverse these relationships and understand them at a much bigger scale. But luckily for us, other teams have wanted to contribute to this system. People are excited to talk about what should it be named, what is the proper meaning of this field, how do we change this moving forward, how do we migrate an old system to this model, and it's spreading. Over the last year, we've had many dozen of apps spin up with their single entity graphs, and we wanted to put them together. So people are really excited to work on this initiative. So over the last year, we've been doing exactly that. We have a team dedicated to building a multi-entity graph, which is a holistic view of all of our content engineering's entities, domains, and operations we can do on them. They've been pulling them into this federated graph. And it's a pretty challenging effort, right? So each team operates independently. They have their own release cycles, their own product managers, their own needs. So it's not coming for free. But the trick is, we've been using GraphQL for a while at Netflix. Well, not really GraphQL, but there's a thing called Falcor, and we've been using that for quite a while as well. It's also a graph database, or graph API, rather. If you haven't heard about it, it basically supports Netflix.com, and it's the way that we fetch data for all the needs of product. It's very different, but it has a lot of similarities. You define the paths of the fields you want to select, and that's only what's returned to the client. So there's a lot of caching, deduplication, references, normalization. Some of the things are in GraphQL, some of them aren't. But the thing about it is we have a lot of experience building graph APIs to support our products. So we've been sharing notes. So we can kind of cheat on this test of learning from the people who've been doing it for the last 5 or 10 years. So they work right next to us, and we've recently had a reorganization to move our two organizations to be a part of the same team. So a single platform team is now going to be maintaining the graphs for both product and for our content engineering space to allow us to move very quickly and learn from all those experts that have been doing this for quite a while. So I'm very interested to see where this goes in the next 6 to 9 months. So I'm excited. But like I mentioned with GraphQL, there are still some challenges that we're trying to face. One of the learnings I wish we had done was talk to the Falcor people much, much earlier. But hey, we're there now, so that's OK. So there's a few things that we still need to figure out. So schema management is a very challenging topic. I've alluded to that it's great if you can align and move in the same direction. But there are many ways to solve this problem. And I really do think that it depends on your organization and the size of your team to do this well. But I'll just go over some of the challenges or ways that you might be able to do this within your teams. Do you define the schema to reflect your UIs, or do you define it to reflect your products? So as I mentioned before, there's a users, a products, a payments, and a reports. Do you take those exact entities, put it into a graph, and expose that to your UIs directly? Or instead, do you say, what do the UIs need exactly, like a gallery or a discounts section, and define the products use cases in the UI in the schema to be easier to consume? There are pros and cons definitely to both approaches. So that's something you'll need to figure out what makes sense for you. And then who owns this schema? Do you have a single team that mandates which changes can be allowed in? Do they say, nope, that doesn't fit our use case, or we're actually going to hold off on that until more teams need it? Again, this can work very well if your organization is small or very large, either way. But it's definitely something that is to be considered. Another approach is, do you instead have informed captains, which is a thing we use at Netflix to derive or to determine who's leading an initiative, basically. But potentially per entity, you have an informed captain that says, here's a schema for our entity, and we're going to be the source of truth for maintaining that and extending that. So if you want to make a change, come talk to us. Is another approach you can take to defining your schemas. Another challenge we've also faced is distributed rights. So everyone talks about GraphQL for reading information, but that's only half of the internet. The other half is changing it. So how do we solve this? So within our domain, we have chosen to only do single entity rights for now. And if we do choose to go down a multi-distributed transaction route, we will have to face very challenging topics at that point. But I believe you can solve this with your job ID and maybe send a finished payload through a subscription or something like this. Or, I don't know. We have yet to solve this case, but it's something we've punted on it until later. Another thing that has been quite challenging to figure out how to do correctly is actually error handling. So in the GraphQL spec, there is an errors part of the response that you get back. But I would argue that that is not what you should use it for. That is more like exceptions, right? So things that your server could not handle. Instead, I would encourage people to look at putting your errors into the schema. For example, if you're loading a user's page and the user's not found, that is a known type of state your app can be in. So your schema should reflect all possible known states. So you might get a user payload back, or a not authorized payload back, or a user not found payload back, and your schema tells you the information you need. Your UIs can be built around that. There's very clever things you can do around client selection sets that allows for moving forward, especially on mobile, that you don't break older clients, but it's implementation detail. But errors, I feel, should be in the schema, and I'm sure I'll get questions around that in a moment, but that's fine. So as I mentioned, those are a few of our challenges, and we have been working very closely with the product team to figure out what can work for us. So on product and streaming, to the best of my knowledge, they've been using the ivory tower bucket of defining the schema. A core team has been maintaining the schema entities and controlling what goes in and what changes. But they've encouraged us to try this new approach where each service owner or domain entity owner, what we're calling domain service entities or whatever, will maintain their own subgraph, and that will get merged into the federated graph. So we're adopting this approach, and we're very interested to see how this plays out. And in regards to, do you make the graph UI-centric or do you make it entity-centric? So we are still evaluating the exact approach to solve here, and I'm on a working group and we're interviewing all of the organization to see what are the exact use cases of each team, but we're evaluating potentially providing a managed experience to put in front of this federated graph that's like a BFF or a back and forth front end for each UI team to potentially do their own data transformations, maybe extend the graph to be more product-centric, but we're still evaluating the needs of the teams before we rush into solving this problem. And the way that we actually do this is through working groups. It's a very interesting way to solve this problem. Instead of prescribing a solution, instead we talk to everyone and we say, what do you actually need? What problems are you facing now? And how can we help you? So this has been very successful for us. And I think it's been probably one of the bigger factors of why I think GraphQL has succeeded in Netflix. There's been lots of interest from product as well as our content space in exploring this. But a lot of the learnings that we've been having, we've been sharing amongst the teams. And I feel like it's just driving it forward in a very nice way. So having this unified graph is really going to allow us to answer questions to product people that we haven't ever been able to answer before because it's been in a siloed system. So once you have this main entity graph or multi-entity graph, it really changes the way that you want to build applications. You don't have to think about talking to this team to get this extended or that team to get that extended. Instead, all the data that's possible in your organization is there, and you just build against it. So within my team, in particular, back to a smaller scope, we want to see how we can stop building applications. Is that possible? What would that look like? So we have a localized innovation lab where we spend one or two people per quarter will basically hack on projects and see what we can do. And we've had some very early initiative things come out of this, which we hope to open source. But what if you could write an entire app without any GraphQL? We use TypeScript. So what if you could just access the data you want, look at the types, map them to props, map that to a GraphQL query, and then send that to the server without writing any GraphQL. So we have a library that kind of does that. Whether or not we use that in production or whether we're not, maybe it's a terrible idea, but it's just interesting, right? What if we could go further and have the schemas and have drag and drop GUIs to make UIs? It's possible if it's all typed. It's very interesting. So come help us solve these fun problems. So if you have any crazy ideas on how we can build new apps or make Studio better for the world, please come speak to me. We're always hiring. So I'll leave you with one final thought. I think GraphQL is amazing, not necessarily for the technology or the tools around it, like Apollo and whatever else. GraphQL wins my heart because I think it changes human behavior. It starts teams talking to each other on how they can evolve and enhance the schema. It's a typed, living source of truth of what the API taxonomy is for your entire organization. And it moves us back to the monolithic dream team. Each teams can be independent and moving quickly, and your monolithic API allows your entire organization to be represented in one place. Together, we can do what we do best, all while bringing everyone together. Thanks.
So I think we have some time for questions. If folks have any questions, you can come up to that mic, or I can come to you if you raise your hand. Any questions for Garrett about GraphQL at Netflix? Yeah.
Hello, thank you for the talk. And I have a question about performance and rate limits. For example, when you manipulate REST API, you can say that, OK, movies is quite fast and not time-consuming, but movies/ID/reviews is very heavy request, and you can't send more than 100. And but for GraphQL, we have like queries and one endpoint. Did you encounter everything? If yes, how will you try to solve this problem?
Yep. So yes. So there are many questions in there. I'll try to answer all of them. So if you want to do rate limiting and complexity analysis of the actual GraphQL query, you can definitely do this. And you can basically be a for filter as a part of the validation of the actual schema. You can say if the complexity of this query is too deep or has too many field selections, reject the query altogether. You can go further to say, here are all the clients' queries that we know about, and we're going to basically whitelist them, and everything else is blacklisted. So you can know exactly which queries are going to run in production and optimize them. In terms of knowing what's being used and knowing the speed of these things, there's amazing tools like Apollo Engine, like I mentioned, but you can also build internal tools. There's basically, in all the open source libraries, there's a spec that gives you timings per field, per resolver to understand your app, basically. And I would encourage you to read Principled GraphQL. It's a one-pager doc that talks about how to build these things in production. And part of that is basically optimize when you have a problem, because it's an end-to-end super complicated problem to know what is every possible combination of queries that I'm going to be receiving. And I feel solve your known use cases, whitelist your queries, persistent queries if you need to do this, in production especially, and then tweak your performance from there. But yes, you can block the request if it's too complicated, if it has too many fields. You can do detection and timings with open source tools like Apollo Engine or Apollo request pipeline, stuff like this. And I would say optimize when you have a problem. That's my suggestions.
Any other questions? Here, I'll come over here.
Hi, thank you for your presentation, and I have additional question to previous one. We have some federated graph with our entities, and for example, we query film, review, and user entity. And what about concurrency and parallelism? Do you use it in Netflix, and how? Okay.
Yep. So we have yet to tackle this problem, but is coming in soon with the work of the federated graph. So the new tooling from Apollo, like Apollo Federation, is going to be open source, or it's open source as of 2 weeks ago. It's very complicated. I would recommend that you go read their docs around how they have actually implemented this. But the way that they do this is they have basically a SQL planner, but for GraphQL planner. And they're able to detect, this is the first ID we must have. We have that ID now. We can make all these in parallel. And then we can go make this last request once we have so the sequential ID from the previous request. So they're trying to optimize chaining the operations which you must do in which order. And that is going to be open sourced. I think there's also a paid thing to the side of that, I suppose. We're evaluating using that or building something similar internally. But that's what the infrastructure team is now dedicated to solving in the coming months. But it is possible. It's just not trivial. If you need it, you'll build it. If not, you'll buy it, I suppose, would be my tooling. But we're not there yet for the actual solution. But I would recommend looking at Apollo Federation, at least how they've gone about solving the problem. And maybe you can build something similar in your team. Another thing I mentioned in terms of performance is you can do data loading, which is a very common way to also speed up apps. So you can cache the requests. You can memorize a request. So for example, if your query is user, comments user, and that you would naturally request user one twice, you can memorize it basically. So if you've already fetched that data per request, you'll get back the same entity in memory as opposed to hitting the API twice. Or you can also data load multiple IDs at once. So you might have a recursive structure that's get the vendors, get the vendors, get the vendors. You might make 100 requests to that service. You can instead batch up the IDs, make one request, and it'll merge it back in the graph. So there's lots of strategies to try to optimize and make this more performance heavy. But I feel that's implementation, and I wanted to get here's the nice things about GraphQL. But
Any more questions for Garrett? Over here.
Hi, thank you for your speech. In terms of GraphQL, what do you guys use or to resolve latency problems when you guys are using GraphQL to reach out to different source systems to pull back information?
Do you mean like if part of the request has failed or in general?
Yeah, like in part of the request fails.
Yeah, so I didn't get into the specifics, but there's a really good talk by this woman. She used to work at Medium, but now she's at Twitter, that talks about error handling. Oh, crap. Oops, sorry. But basically, I would put that into the schema. If something can fail and you know it can fail, it depends on the type of issue it is. But for example, an unauthorized system, like if that's a different type of error than like an intermittent, this thing, if you retry it, it'll be fine. But we design our systems and our schema to basically everything can be nullable, and the UI can handle something being null. And if there's actually business rules that say like this can never not be blank or something, then sure, make that a required field and throw up an exception in your server. But in terms of intermittent failures, I mean, you could do retry logic in the resolver. We do that in some scenarios where we try a couple times before we actually bail out of the resolver. But we don't have like a uniform, this is the best way to solve this problem generically. But I feel like it really it depends on your type of error. And if you can retry, go for it. If it's something that can be null, let it be null in the schema. Or if it's like an actual, that's going to cause a business logic error, then like put that error into the schema that you can reflect better to your users as like what's actually gone wrong. Hopefully that helps. I don't know.
I saw some other hands. More questions?
Hello. How do you resolve the situation when you have multiple teams using essentially the same business entity, but they have a, let's say, different view of the entity, that they want to use different data? I suppose you do not want to load the entity with all the fields, etc.
Yes, most definitely. This is obviously going to be challenging, but user, for example, I would imagine every subsystem to have, or not everyone, but most people are going to have a user entity in their system, and they may have different fields or different representations of that. So with this federation thing from Apollo and the open source thing, they basically, each subgraph extends the basic type, and only one team will actually own the main type. And if there's any merge resolution conflicts, you'll get that in editor with amazing tooling. Like you can get query timing, you can get per field level timing, you can get like, you know, someone else has this has an ID, you have it as a string, that's invalid. So I mentioned in my diagram, like my second diagram of the schema registry, and that's where it comes into place. Basically, each team locally and in production and every environment builds against this schema registry. And as a part of your deployments, it basically validates that, yes, this won't break any clients. Yes, this merges with all the other entities fairly well. And if it doesn't, it'll get like a build error or a PR error, and you can go further dig into this. But basically, to summarize, each team can extend these user types that are shared or entity types that are shared. And as a part of your validation deployment step, with the help of a schema registry, you can actually validate and check that that's not going to break the bigger system, if that makes sense.
Hi, I was wondering if you could elaborate a little bit on how you guys enumerated business logic errors, specifically around like kind of the implementation. Are they like first-class types, or are they fields on a
Sure.
type?
So again, this is still like a ever-evolving topic, and there's the GraphQL Paris conference that happened last week, and there's a talk explicitly on this. I believe her name is, I'd have to look it up, sorry, but look up GraphQL Paris errors, and you'll find her talk. But she's amazing. She used to work at Medium, now she works at Twitter. But basically, you define a union type. So instead of you say, I want users1 as your query, and you get a user object back, what happens if that user didn't come back, right? Maybe there's not a user1 in your system. And instead, your resolvers or your query's return type would be a user payload or 404 or unauthorized, and those are other types. And then they may have specific fields of the errors or the validation rules or whatever message you want to use to display that in their UI. And then as a client developer, when you, like, for example, if you use like React Apollo, you do like a query component, and you switch on the data, and you do like a union, and you say like, if it's this type, render this component. If it's this type, render this component. So you can actually have better represented errors to your users, like as opposed to like a big banner on the top being like, uh-oh. You can actually show like, you can redirect them back to the flow you want them to go to if you know exactly what broke, as opposed to like digging into the data.errors array and like there's like 100 field selections in there. So if you can co-locate your data requests and your errors, you're going to have a much better time as a UI developer. And you can actually reason about why things break, as opposed to like you as a consumer having to figure out why something might have broken.
Come over.
How do you deal with, as your teams are growing and you're moving into this federated graph, how do you deal with breaking changes that may be introduced from other teams, changing types even in small ways? Is there some sort of system that you handle it, that you use in CI that gives you like some sort of log file for type changes? Or?
Yep. So we are currently using Apollo Engine, which is basically in production. Every request will, all the timing and queries information will go to their system and it gets logged. And then at even development time in your editor, you can like have your little GraphQL tag in your editor, and it'll give you timings. Like this field costs this much time, and it uses production data to like give you that field by field. But as well as like locally, you can do Apollo check. Or put this into a CI Jenkins job or whatever you're using for CI to basically say like, here's the schema that we're going to publish. Does that meet all of our clients' specifications, and does that match against production like traffic over the last couple of months? Like not only does that type match, but does it match like production usage of this? It doesn't get into the rules of like, is this correct for your business? But I feel like that's where PRs would come in. But at least the timing and like the usage of that graph can be checked with these toolings. So we do this as a part of our like, and that's where the registry kind of comes into play as well. Like you wouldn't be able to actually publish a schema if it broke your known client's usage of this. And in terms of how we do version changes, like again, I'm still mentioning this because it's being developed actively at the moment, but I would roll forward with new fields, new messages, new queries if you're going to make breaking changes in almost all scenarios if it's possible.
Saw another hand somewhere. Yep.
Hi there, thanks for the talk. I just got a question, if you could elaborate on your investigation and from a tech stack point of view, why you would choose GraphQL over another query language, say like OData.
I can't speak to that because I do not know the other one. Sorry about this. But I have only had a nice experience with GraphQL as of yet. I do think it's probably more it allows your UIs to move very quickly. I feel like, and that is a huge advantage as opposed to not using GraphQL. I think it's client-centric, but that's not to say that you can't use it from server to server. But if you are to do this, I would like there's gRPC, there's other nice toolings that have like two-way data streaming and stuff like this. But I would think it's optimized for clients, especially, and it's made by Facebook, and it's all that rage. So maybe there is some hype to it, but I have only had good experiences with it so far. So, but I can't speak to the other one. So.
Yes, please. Thank you. Regarding the teams, is there a methodology that you are using in the communication of the teams, so you can communicate with the teams through this tool or this methodology?
Do you mean in terms of the schema design?
Yeah.
We do have these working groups where we talk more generally, I suppose, around like, should we do the relay for pagination? Should we do this for errors? Like, we have this kind of forum to discuss these things more publicly, I suppose. But now with this new reorganization of both product and content engineering merging, we do have a dedicated team to be building out these federated entity graphs, and they're kind of just making these decisions at the moment. But the ultimate goal is like these per teams will maintain their own graphs themselves. But yeah, that's something to consider, like how we can enable these teams to elaborate more effectively, especially if they're dealing with like multiple entities across multiple domains, like extending them and not conflicting with this. I feel like as soon as you go to this distributed model, you do need tooling and communication to do this well. So that's something to be mindful of, but I don't have a clear answer for the best way.
Time for a couple more questions, if there are any. More hands? Oh, up here, okay. Coming up.
Hi, and thank you for your talk. My question is, how do you determine when a graph is needed? Do you build a graph for every feature of your product? And particularly what I'm interested in is, as your product becomes larger, how do you prevent a proliferation of all of these graphs where there's some type of duplication of effort in places and bits of your product?
That's definitely a fair concern. As of yet, our teams and many teams have been using this are 100% on the GraphQL like interface for dealing with the backends. But I can imagine a world where if you're doing like CQRS or like you're doing file uploads or something that like doesn't fit that paradigm, or you're doing streaming. I mean, you could use subscriptions, but that's like less used as of yet. You might want to go out of that scope. But as for us, we find we have no need to not use the graph for all of our use cases so far. In terms of bloat and like over time getting too big, I feel like that's just a matter of like versioning and like deprecating fields if you really want to remove them. In terms of like adding new things, I think that's more of an organizational problem to try to solve. Like, do you really need 5 user systems, or can all be within one? Again, I don't know. We haven't gotten to that stage of that maturity for us to have a good answer for that. So I do not know.
So one more hand somewhere over here.
Hi, thanks for your talk. So my question is just about coupling. I think it's been covered by a few questions already, but I'm just curious about your long-term deprecation strategies. So for instance, with your federated graphs, if you have to stop kind of this bloat that people have mentioned and sort of having these kind of older entities hang around for like 5-10 years because some other teams may be using it, do you have maybe a more aggressive deprecation strategy that you've been talking about internally?
So at Netflix, we don't tell anyone what to do. Everyone has the freedom and responsibility to do what they want to do, and the judgment comes into that. So like, what things should we be focusing on? What things should we do? But to the best of my knowledge, I could be wrong. Don't quote me on this, but I believe Facebook has never deprecated a single API they've ever made, and they're doing fine. So I don't know around like getting rid of old things. I'm sure there are good strategies for that. If you control all of your clients, you can just say you need to upgrade in the next quarter or something, and we're going to turn the old one off. Great. If you have that luxury, I think that's fine. We don't control every single client that uses our app, right? So, and we can't tell people what to do. So it's just a matter of being like, please move to the new ones. You get new features. So it's like convince them with the new shiny, maybe. I don't know. But we have yet to run into this problem, and I would really be curious to know if it actually becomes one. Personally, I don't know.
One more question.
Okay. So I haven't really used GraphQL myself, but I read a good amount of literature about it. I'm kind of concerned about one thing. So from what I understand, for each query, you still need to write a resolver, which is the way I see it from outside is more like writing an API, a REST API, a REST endpoint. So you still need to implement the resolver for it. So do you see the advantage of GraphQL in the power of expressing queries in a way which I don't understand yet, or do you see more in the fact that because you have that Uber taxonomy, you can make those queries more powerful? I mean, the simple fact that you have that taxonomy kind of gives the entire organization a common understanding and allows those queries. So do you see it more in the intrinsic query power or more in the taxonomy, the advantages that taxonomy gives you?
I think both, personally. So as a UI engineer, like you can go to this graph through. I should have shown an example, but it's not a very specific talk. But as a consumer, you can just go like Command Tab and see all the queries that are available. You go into there, you Command Tab what fields are available with the description and the type, and you just keep digging down as a UI engineer, and you're like, oh, I want this, and I want this, this, and this, and that's the only data you get back. It's very nice as a UI engineer. You don't have to worry about. I get this from this REST endpoint. Okay, in that big JSON body, I get an ID. I go somewhere else, get some more. It may be in an included batch. But I feel like it definitely helps the consumer of the API get just what they need when they need it. And I feel like the taxonomy of the documentation of your entire system is also very appealing. To speak to the REST resolver implementation comparison, I think it's just a transport layer way to define how to get data, or it's like the boundary of your system. So you're still going to have to implement it, I think, at some level. But I think the bigger benefit is for the clients, I would imagine.
Cool. Can we have a round of applause for Garrett, please? Thank you, everybody, for coming.